So good morning, everyone. My name is Bas Rodenburg. I'm professor of animal welfare at Utrecht University in the Netherlands at the Faculty of Veterinary Medicine. And today I want to present two cases to you on validation of slaughterhouse technology. The first one is focusing on a smart camera system in a pig slaughterhouse that the validation study we conducted for the Dutch government. This is not part of the aWISH project, but the sensor is included in one of the aWISH pilots. And in the second presentation, I will focus on validation of two welfare indicators in broiler chickens. So first, focus on the pig slaughterhouse. So I'm not sure how familiar you are with conventional slaughterhouse surveillance by the authorities, but in the Netherlands and probably also in other countries in Europe, we see that the inspectors are limited in number and also in available time. Inspectors often have to oversee a large slaughterhouse facility, and they have multiple responsibilities. They both have to look after animal welfare and food safety aspects, so they have a lot on their plate. Increasingly, they also use conventional camera systems or CCTV systems, where they can collect recordings, for instance, when animals are delivered during the night to the large area to wait for slaughter. Then they can watch this video footage and to look for things that are deviating from what is allowed from the regulations. But of course, when you have to watch these videos manually, so to say, you have the same time constraints as for your live inspections. So solutions are needed to address this. One development that we see in the field is smart slaughterhouse surveillance, where cameras and potentially also other sensors like RFID sensors, for instance, help to oversee the different stages within the slaughterhouse. And it works as follows. So there is a camera system, but this is a smart camera system. I will explain more further on in the presentation. That is basically continuously monitoring the process. For instance, a camera system at unloading continuously films the trucks arriving, the doors opening, and the pigs coming out of the lorry. In this case, you can imagine that there is a normal flow of pigs and of people, pigs coming down the truck, walking towards the large area, whereas there can also be deviations from this normal situation, where pigs are not moving or humans are moving between the pigs or the pigs are moving in the wrong direction. Well, this system, this smart camera system, is trained to detect these deviations from normal. And if these happen, footage is recorded of this event and sent to the welfare officer for evaluation. And then the operator or the welfare officer evaluates the footage and takes action in case of a true positive, so in case something happens that should not be happening in the slaughterhouse. I have a short video, so I might just try to switch to this image. Let me see, share the sound. No, this one. I hope that it works.
There is an increasing need to better monitor how animals are being handled in slaughterhouses. This has raised the demand for more and better camera surveillance. But although traditional camera systems can help spot welfare issues, they have limitations. Since it's impossible to review all footage, slaughterhouses tend to review a random selection. So most of the footage, and therefore potential welfare issues, remain unseen. That's why Deloitte, the Dierenbescherming, Eyes on Animals, and FION have developed an AI tool to make these camera systems more effective. So, how does that work? The tool uses AI technology to detect objects in the video frames, like persons, pigs, a stunning device, and paddles. Their movements are analysed to determine potential issues, such as a pig staying behind. This could mean the pig is lame and is hurt, or a group of pigs moving in one spot. This indicates a bottleneck where the pigs can get stressed. These fragments are automatically selected from hours of video, so welfare issues can be reviewed. This dashboard enables welfare officers to take action and continuously improve animal welfare. Want to know more? Contact us.
So that's a short explanation of the system. Now I'll move back to the slideshow. Yes. Can you see the presentation again?
Yes. Yes.
Yeah. So as you saw in the short video, you can detect deviating patterns. Here you see a screenshot of the system in the unloading dock. Here the trucks are arriving in the back. And you can see the blue squares around the pigs. You can see the red squares around the humans. These are blurred to prevent privacy issues. The green square in the back is the stunner, the mobile stunner that can be used if a pig is very lame and unable to move. Then it can be stunned there in the unloading area, any emergency slaughter. And this type of movements can be detected. So humans moving in an unexpected direction, the stunner is moving or not moving, the pig movement, and that you can apply in different places in the slaughterhouse to detect different things that you are interested in, where you want to have oversight. Of course, this would be very good to have such a system, but at the same time, we also need to be sure that the system is really measuring what it is supposed to be measuring. Some of these events we'll look later, for instance, at signs of life after bleeding, and you can imagine that this is very rare in a commercial slaughterhouse. But still, if it happens, it's a very serious problem. So you want to be sure that you also detect it when it's a very rare event. And so you don't want to miss detections. You also don't want to collect many irrelevant detections. For instance, if you look at unloading and you look at the use of a pedal to drive the pigs, you don't want to detect many video clips where actually there is no pedal present, and the pigs are not driven with aids and with pedals or with things to hit the pigs, for instance. And so you don't want to collect many irrelevant detections because then the welfare officer gets stuck in all this irrelevant footage. So what we did in this validation study was to compare with detailed human observations as a golden standard to see if the system was detecting the true positives in a good way. So for this validation study, we selected two relevant indicators. One was the use of a low voltage electrical prod that the slaughterhouse used to drive the pigs into the electrical stunner. This slaughterhouse uses the Midas electrical stunning device, and there they quite commonly have this low voltage prod to make sure the pigs move into the stunning device. This was quite common, the use of this prod, so that was something that we could observe in a large number of cases and compare the human observation to the system observation. The second one I mentioned already, so that was the signs of life before entering the scalding tank. So this is after stunning and after bleeding, so after killing the animal. The animal should then be dead and motionless at this stage of slaughter. And then it enters the scalding tank, which contains water of 60 degrees Celsius. So you want to be sure that the pig is dead at this point. Luckily, this happens. This happens very rarely. That pigs are still not dead and still show signs of life at this stage. But you want to detect it should it happen. So first, for the use of the electrical prod at the stunner. There we evaluated 20 videos of 10 minutes, each of the stunning area, and that was selected by us from a longer period of time and from both of the stunning areas that were present in the slaughterhouse. The AI algorithm was trained to detect the human holding or not holding the prod. So it was not about use of the prod, but holding the prod in the hand. So that was also what we observed as human observers. So we tried to create a protocol that was very similar to the training protocol used for the algorithm, including the detection area close to the stunner that we focused on for the observations. In these 20 videos of 10 minutes, we detected 461 events of a human holding the electrical prod. And then, based on these observations, we compared the human observation and the system observation, and we calculated the accuracy, the sensitivity, the specificity, and the precision. And the aim was that these should all be above 80%, so that 80% of cases were detected correctly. Well, we saw that this was the case. So the majority of cases, here you can see the gold standard, so the trained human observer on the x-axis, so to say, and the system, the algorithm on the y-axis. About 40% of cases were evaluated as positive both by the system and by the human. 43% both negative by the system and by the human. And there were 8.4% of cases where the trained human observer did not observe the human holding the prod, but the system did, so the false positives, and 8.7% were missed by the systems, so they were the false negative cases. So this resulted in all the different indicators, the accuracy, sensitivity, specificity, and precision to all be above 80%. So this was our goal for the evaluation. And if you consider the false positives and the false negatives, so the 8.4% false positives will be reported to the operator, so they will appear as clips on the dashboard for the operator to check. And they will be removed at that stage because the operator can confirm that the human is not holding the prod in those video clips. And those clips can also be shared with the developer of the algorithm, in this case Deloitte, to further train the algorithm. The 8.7% false negatives, these were events that were actually missed. But it's good to realize that with a system like this, there is continuous monitoring of the process. So if you think back to this single inspector that takes snapshots of the process and that sees, that can only look for a limited amount of time, both in the case of live observations and in the case of evaluating CCTV footage, you will still see far more with the smart camera system compared with human observation. So even if you miss 8.7%, you will still see probably, I find it difficult to guess, but maybe 10 times more or even more dramatic differences compared to the traditional oversight by the human inspector. So the second part of the evaluation study focused on the signs of life before the scalding tank. As I said, this was very rare. During the evaluation study, we did not observe it happening in real life in the slaughterhouse. So we decided to simulate the signs of life. This can be done by using the mobile stunner, the emergency stunner that's present just before the scalding tank, where pigs can still be stunned if they show signs of life. And if you use this stunner, you also stimulate the carcass, so the legs will also respond. So it will look like a pig is moving on the slaughter line, even though it's already dead at this stage. So there we decided, we developed a small protocol to stimulate the carcass briefly in the middle of the carcass 3 times with this mobile stunner. And then you see in response that the front and the hind legs move upwards and downwards, and you have a clear movement at the slaughter line. And then one of our team was standing at the slaughter line, noting the time points of the stimulations and also observing the movement of the carcass. And then we compared with the dashboard, the time points in the dashboard, whether all these events were also detected by the system. So we had 2 sessions where we did this in the end of 2023 and the beginning of 2024. The first time in December, we had 10 simulations where we stimulated the carcass 3 times briefly with 90 seconds in between. So we skipped a few carcasses and then stimulated again one of the carcasses, and those were detected in 100% of the cases. And in January 2024, we again stimulated 20 carcasses 3 times briefly, and again had 100% detection. And then we also looked at a sort of milder stimulation where we only used 1 time brief stimulation. Then you get movements that are a bit more natural. Just once the legs are moving at the slaughter line. And then also in 90% of the cases, the system still detected this movement. So this can be ways to still validate very rare events by a simulation study. We also recommended that this can be important for keeping the system sensitive, because when something happens maybe once a week or twice a week or once a month or once a year even, you still want to be sure, especially with things that are very serious, like signs of life before the scalding tank, you want to be sure that you detect these events. So for instance, a monthly simulation session where you do something like this can be important to check if the system is still sensitive to movement. And so if we look at those results, for the use of the electrical prod, we saw that all the parameters were well above 80%. And this was also the expected range between 0.7 and 0.9. Also, if you look at other studies, at the same time, very few studies are available to compare with. There's quite a lot of different sensor systems being used in slaughterhouses, but a recent study from the Netherlands showed that only 20% of slaughterhouse sensors have actually been externally validated. For the signs of life detection, we saw that all simulations were detected when the same protocol was used as for training the algorithm, because also for training the algorithm, they used electrical stimulation of the carcass to simulate movement. And as I said, these are rare events, so it would be very good to repeat this type of simulations regularly to check that the system is still sensitive. So for the 2 indicators that we validated, we saw that the AI for animal systems provides a valid solution for smart monitoring with all indicators over 0.82. And additional benefits are observed from the mandatory evaluation of the footage by the slaughterhouse personnel. So this system really comes with a obligation for the slaughterhouse to also evaluate the footage that is selected by the system. And there you have this 2 directions. The false positives can be taken out by the welfare officer and shared with the developer to further improve the algorithm. And the true positives, of course, there the slaughterhouse can take action and also has to report back to the company that developed the algorithm how they handled these events, and also to see if you can, for instance, reduce things. If you would like to reduce the prod use in the slaughterhouse, you can use the data to see how you're making progress in this area. And this is something that the slaughterhouse that we did the that where we did the validation study has already used this to change the protocols for use of the prod. And also to do more detailed observations of the stunning area to really see how the prod is used on the pigs also. Yeah, so this was the end of the first part, funded by the ministry. Thanks to the project partners and for Deloitte for sharing their information on development of the algorithm, and thanks to the participating slaughterhouse. I think maybe at this point it would be good for this part to have some questions. I don't know if there are questions in the room.
Are there questions from your side? Not yet. No?
Not yet?
No, not yet.
Okay, then we continue with the broiler part.
Yeah.
If there are, then we can take them in the end, maybe.
Yeah.
Yeah. I'm now at the end of the presentation. There we go. Are you seeing the slides again?
Yes, yes.
Yeah, good.
Perfect. Thank
Yeah,
you.
so the second part, oh, sorry, is part of the aWISH project. That's a validation study on automatic assessment of foot pad dermatitis and hockburn in broilers that we conducted. I'm not sure if you are familiar with these issues in broilers, but foot pad dermatitis and hockburn are quite common welfare problems in broilers approaching slaughter weight. So in fast-growing broilers between 4 and 6 weeks of age, you can see these developing. There is a relationship with poor litter quality, sort of high moisture, high ammonia levels in the litter, poor ventilation, also with low activity levels, heavier birds sitting down on the litter. When the litter is then of poor quality, the risk of this type of contact dermatitis developing is quite high. And also when they're walking around in poor litter quality, you also increase the risk of foot pad dermatitis. And also there's been associations with high stocking densities towards the end of the growing period. Yeah, the barn can be quite full of birds. So yeah, foot pad dermatitis especially, but also hockburn are commonly used as important welfare indicators in broilers. At the same time, if you want to assess these indicators on farm, that is quite challenging. It requires catching of the birds, handling of the birds. You have large flocks, you might cause a panic with highly pathogenic avian influenza. Access to farms is very limited at the moment, so this is very difficult to organize. At the same time, from the legislation perspective, in 2007, the European Broiler Directive came into place, and that was the first directive that included animal-based indicators. If you want to keep broilers at higher stocking densities, then you have to be able to show that you have relatively low mortality levels and that you have low incidences of a low incidence of foot pad dermatitis. So those are included in the legislation, and that also led to the development of automatic systems to assess foot pad dermatitis and hockburn at slaughter. And you can imagine that this has major advantages because all birds pass in the slaughterhouse, of course. And there you can look at the number of birds. If you have a system that can check all the feet and all the hocks, then you have the whole flock and you can look at the percentage of the flock with a certain score to look at the problems with foot pad dermatitis and hockburn. For foot pad dermatitis, there are, and also for hockburn, there are scoring systems that are quite common. This is the one, for instance, that's used in Germany and also in the Netherlands, the QS system, where you have 4 categories. On the top left, you see a healthy foot pad. footpad. Below you see a score 1. So when there's minor footpad dermatitis developing. On the right hand side you see 2A and 2B, more severe cases of footpad dermatitis, where it depends on the sort of the size of the area, the percentage of the footpad that is affected, whether it is a score 2A or 2B. And especially those 2A and 2B scores are to be are sort of the major welfare issue that you want to avoid. Here you see the system in action. This is the chicken check system developed by CLK in Germany. So that's after the walking feet have already been removed from the carcass. You can see that there's, oh, sorry. Oh, that goes a little bit too fast. Yeah, there's slides and you can take pictures of the footpads similar to what we just saw in the previous slide. And the algorithm is trained to detect color differences, to detect the dark area inside the yellow area. And in this case, the size of the lesion determines the severity. So the size of the affected area determines the severity. And in the case of footpad dermatitis, it's the percentage of the footpad that is affected by footpad dermatitis. For the hog burns, it's similar. So here you see the birds on the slaughter line after plucking, and you can see the hog camera. So taking pictures of the hogs. In this case, I don't see many issues with the hogs that are passing now, but it is quite common to see these hog burns as well. And there again, it's about color differences. Here, it's not the percentage of the area that is affected, but it's actually the size of the lesion that is used to translate into the score. There have been previous validation studies of these traits using the same system, the chicken check system, by Lauten et al. From Germany in 2022. They did an internal validation study in the slaughterhouse where the system was first employed. They used a 5-point scale, so slightly different from the scale that I just showed and the scale that we used in the current study. They used 200 feet for calibration and then 500 feet for validation. And the way that they worked was that the trained observer scored the feet by looking at them in hand. So to really have the observer had physical access to the feet before they were analyzed by the system. And in that way, the observer scored the feet. That's the macro score that you can see in the figure on the y-axis. That's the score given by the human observer. And then this was compared with the automated system. And then they had this 5-point score that you can see on the y-axis, and they compared this with the camera score. And what they saw was that they can quite clearly detect the different categories. So like the 0 category, the 2 category, and the 3 category. You can see in the figure that these are sort of 3 different clusters, where it is more difficult to differentiate between 0 and 1 or 1 and 2, and also between 3 and 4. So if categories are closer together, it gets more difficult to separate the scores. And they use the human as golden standard and try to train the system further to further improve the camera score. You can see on the right-hand side of the figure this updated camera score. So there they try to use the information from the human observer to further improve the scores given by the camera system. They did something similar for the hog burns. So in the picture above here, you can see some examples of the hog burn score. Here they also used a 5-point scale. So that was different from what we did. Again, 200 hogs for calibration and 500 for validation. And then they also saw that the system was able to separate small and large lesions. If you look at the scores again, you can again see that, for instance, score 4 is clearly separated from the other scores, score 3 as well, whereas 0, 1, and 2 are quite close together and difficult to distinguish. So they also concluded in this study that large lesions were more reliably identified than small lesions. We took a slightly different approach in our validation study, and we also aimed to have an external validation. So we worked in different slaughterhouses. We used data from 2 different slaughterhouses, one in Poland and one in Denmark. We used the same system as in the Loudon study, but we actually wanted to evaluate the severity of the lesions from the same picture. So the human observers got access to the same material as the camera system. In this case, you can see a picture from the system, from the CLK chicken check system. You can see, if you look closely, there's a red area, a red line around the footpad lesion and a green line around the whole area of the footpad. And what the system does is to look at the percentage of area of the footpad that is affected. So the red area compared to the green area. What we did was to have 3 human assessors. They all had experience with footpad dermatitis and hockburn scoring, and they received pictures from the 2 different slaughterhouses, one in France from our pilot there and one in Poland. They used a training data set of 50 images, 100 feet and 100 hocks. And that data set was also used to discuss the scores afterwards and to look at can we reach agreement on scores so that we also score the footpads and the hocks in the same way. And then a validation data set was scored 500 images, and this was done, of course, separately for the 3 different assessors. So 1,000 feet and 1,000 hocks. And then we compared the humans and the system. Now here you can already see an example. So for instance, this foot here on the left-hand side in the picture was evaluated. Here you can see the 3 scores from the 3 humans. So there was a score 1, a score 2A, and a score 2B. So that's quite a range. Whereas score 2A is a little bit in the middle. This is the most severe score, and this is a less severe score. And the system calculated, well, this is 26% of the footpad. So according to the algorithm, that should be a score 2A. And that was a little bit what we observed in this first part of the validation. If the humans have to translate their observation into a score, it is very difficult for a human to detect that this is 26% of the footpad. When I would ask you to come up with this answer, I would get many different answers, I'm sure. So that's also what came out. If we look at the 3 different scorers, those scores are given in red, green, and brown. For the different categories, the top panel is the footpad dermatitis, and the bottom panel is the hockburn. And actually, in both cases, the result was quite similar. So in blue, you see the scores of the camera system, and especially for the lower scores, the camera system was much less variable than the human. And this larger variation at the higher score is also, once the score is in the most severe category, it also becomes less important whether it is half of the footpad or 3/4 of the footpad that is affected. So there is more variation in this higher category. But we saw that the humans had only a fair to moderate agreement with each other. So if we compare the scores of the humans with each other, but with the system, the comparison was actually moderate to substantial. So the system was sort of in the middle, as we also saw in this example that I showed in the previous slide. And there we concluded, okay, if we want to complete this validation study, we probably have to think of a different way for the human to get a good score. So it's difficult to assess the percentage of the affected area and translate this into a score. So what we did instead was to have this exercise where the system selects the footpad and the affected area. What if we have that done by a human as well? So compare the size of the selected area, and then we can believe that the computer, the algorithm is able to estimate which percentage of the footpad is affected. So the humans were asked to draw the same line as the system, and then those selected areas were compared to each other. And indeed, what we saw then, I'm trying to remove the video stream. Yeah. We saw that the human assessors and the camera system indeed indicated a similar size of lesions, both for the footpad and for the hockburn, with very high correlations, as you can also see in the picture. So on the y-axis you have the score by the camera system, and on the x-axis the average score of the three raters, both for footpad dermatitis and for hockburn. So the size of the lesions is correctly annotated by the chicken check system, and in this way we can also show that the system is validated to assess these scores automatically. How can we then use this type of data if we want to use it for welfare improvement within the chain? Of course, broilers have a very relatively short growing period of 6 to 8 weeks. So there's not so much that you can do regarding welfare improvement within a round. But of course, you can use data of a given farm or a given chain to improve performance over time for the next round. Here you can see some data from the aWISH data platform, where the orange bars represent footpad scores of batches that were delivered to the slaughterhouse, and the blue line basically shows the trend of these data over time of a given farm. And in this way, you can, of course, evaluate how farms are performing over time. And you can also ask farmers to make improvements, for instance, to pay more attention to ventilation, to improve litter quality, to add fresh litter, to reduce stocking density. All kinds of measures are possible. This also links to the best practices that were developed in the aWISH project. And then you can evaluate, using the automated system, how these changes on the farm are actually affecting the incidence of footpad dermatitis and hockburn. And keep in mind that these are related to poor litter quality, etc. So this is a wider issue that is covered. Here on the right-hand side, you can also see an example of a comparison across farms, where you have multiple farms in the same figure. Green is the 0 score and red is the 2B score. So for instance, here you see one farm, the second from the top, that has quite a large percentage of animals in the highest category. And that is actually could be a reason to discuss with this farmer what could be improved on your farm, how can we reduce the incidence of footpad dermatitis, and you can also compare yourself as a farmer to your colleagues. You can discuss with your advisors if you want to improve in a certain area. So this can be quite valuable. And for instance, you can also compare with other data. Here on the left-hand side is the data, an example from the aBene app. That's a welfare assessment app that we used on farm in both the French and the Polish pilots, where a trained observer does an assessment of the whole farm and looks at things like feed availability, water availability, possibilities for natural behavior, health of the animals, etc. And you get these quite simple radar plots or spiderweb plots where you can immediately see how is my farm performing compared to others, and how is my farm how is my farm doing in general, but also, for instance, on the left-hand side, you can see I think it's natural behavior, where most farms score a little bit lower. Well, this could be an area where you make improvements. And if you can connect data like this from these welfare assessments also to the footpad scores, you can get quite an integrated picture of broiler welfare on these farms and in this production chain. And so what we saw in this validation study, that automatic assessment of footpad dermatitis and hockburn is a valuable tool, and it helps you to collect some welfare data at slaughter. Of course, it would be great if you can connect it to other sources of data. We were able to validate the chicken check system with human assessors. you have to think sometimes a little bit when you do a validation study, how can I also make the comparison sort of fair? If you find that for humans it's very difficult to estimate the size of an area that is affected, well, then the drawing exercise worked very well to see if we come up with similar sizes from the system, from the system's perspective and from the human observer's perspective. And this whole approach offers perspective for practical broiler welfare assessment, especially when it can be combined with other welfare data. And with that, I would like to thank you for your attention and happy to answer any questions.